Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 13 in our incredible new tutorial series where you're teaching your Raspberry Pi who's boss. What I'm going to need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice. No sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this incredible series of video lessons. And in these lessons, we are using the most excellent Sunfounder Ultimate Raspberry Pi Kit. Hopefully, most of you guys already have your gear, but if you don't have your gear yet, look down in the description. There is a link over to Amazon where you can pick up a kit. And believe me, your life and my life will be much easier if we are working on identical hardware. But enough of this shameless advertising. Let's talk about what I am going to teach you today. And what we're going to do is we're going to look at my solution to the homework assignment that I gave you in lesson number 12. And what that homework assignment was to take the circuit that we had in lesson number 12, where we were controlling the RGB LED with 3 buttons. One button was on and off for red, one button was on and off for green, and one button was on and off for blue, where we could turn it red, we could turn it green, or we could turn it blue. Well, what your homework was to go away, and instead of just having red on off, green on off, blue on off, to be able to adjust the red and the green and the blue values to mix colors to get that RGB LED exactly the color you want it. Any color, not just RGB, but mixed colors to get the entire rainbow. The rainbow. Okay, and that's what the homework assignment was. Oh, look, we got a fisherman going by. I know how you guys love to see the fisherman. So little indigenous fishermen trying to earn a living out there. You know, I can actually go flag the fisherman down when I want a nice fresh caught tilapia. I just go down, wave, they run over, and I get a deal on a fish. But I digress. How many of you guys were successful with the homework? If you were successful, leave a comment down below. I am legend. And if you were not successful, leave a comment down below. I folded up like a cheap Walmart lawn chair. Okay. I'm hoping most of you guys got this homework because it really was a straightforward combination of methods and techniques that we already learned in the other lessons. Now, I'm kind of deliberately doing these lessons so that I create a new assignment that pulls together different things that you learned from old assignments so that you sort of learn how to put things together, and then also you're reviewing and gaining more expertise with some of the techniques and methods that we learned earlier. And so I hope that actually makes sense. Yeah, there goes our friendly fisherman. I find it very peaceful and calming just as I'm working here to look out and see those guys out on the river catching their fish and providing for their families through good, honest work. But again, I digress. So let's jump in and let's talk about what we're going to do today. Let's go to our overhead view, and this is going to show, if I get out of your way, this is going to show the circuit that we ended up with last time. And I think that I will probably, you guys can go back and watch the last video if you want to, if you haven't seen it, to figure out what we're doing. But I'll show you the schematic right here. And the schematic is we have an RGB LED. The red channel is the leg of the LED on the left. The long leg is there, the second pin that I have hooked to ground. But the R channel is going through a current limiting resistor, 330 ohms, and it is going to pin 37. The lower left pin is pin 39. That is what we're doing for ground. You can see from pin 39, we are hopping over and creating a ground rail. And then the pin above that is 37. That is our red channel. Then to the right of the ground over here, we have our green channel. And through a 330 ohm resistor, we are hooking to pin 35, and then the blue channel, the one on the right, through a 330 ohm resistor is going to pin, let's see, that's 39, 37, 35 to pin 33. And I'm just going to glance over here to make sure that I'm saying that right. Yeah, it's 37, 35, 33 are our 3 channels. And so that is how we're controlling the LED. This is like the 3rd lesson that we have done this in, and so you guys ought to kind of understand that by now. And then over here we have the red button, we have the green button, and we have the blue button from the Most Excellent Sunfounder kit. And guys, just know that those are those big push buttons, and the little colored covers are sort of separate. So you've got to get those from a different little bag if you haven't put this together already. And so then what we have is we are not using circuit pull-up resistors because we're using the internal pull-up resistors on the Raspberry Pi. And so we have the red channel going to the Most Excellent, the red button going to the Most Excellent pin 11, and then the green button is going to pin 13, and the blue button is going to pin 15. So it's 11, 13, and 15 on those buttons. And then the right leg of the buttons are all hooked to our ground rail. And so that should be everything that you need to know in order to get your circuit set up like mine. Now I'm going to actually move this up here so we are going to be able to see the Raspberry Pi, see our circuit view, and then also we will need to come over here and we will need to be able to see the code view. Okay, what is our goal? Our goal is to be able to mix colors. And so if I press the red button once, it should just barely come on red. And then every time I press it, it should get brighter and brighter and brighter, but I can't go above 100. In fact, I can't go above 99. And so if it gets more than 99, we circle back around. So I don't have a red up and a red down button. I have one button, it's the red button. It goes up until it gets to 99, or if it gets more than 99, then it circles back around and starts back at a little under 1, and I'll explain that. In a minute as far as how I'm thinking about it. Okay, so I will need you to fire up a Most Excellent terminal window, and then what we are going to do is we are going to nano, and we're going to nano down into our Python folder, and then I'm just going to call it dim rgb.py, and hopefully there's not a program there. Okay, good. Fresh new Python program, just waiting for you to write it. Now, I'm going to try to be logical in the way that I name my pins, and because of that, I'm going to be able to go through pretty quickly and put some thought into your variable names. Guys, giving good variable names is one of the best programming practices that you can learn. And so watch how I'm doing these variables. You guys watch how I'm doing these variables, because I'm naming them quite deliberately and quite analogously so that I can code quickly. Well, if we're going to play with those GPIO pins, we're going to need to import our old friend uppercase R, uppercase P, lowercase I dot GPIO. We'll import that as GPIO. You can import it as anything you want, but GPIO makes kind of sense from time. Import sleep, because we will need to have some delays in here. Let's go ahead and set up our delay time DT as 0.1. That would be 1/10 of a second. Let's go ahead and set up our RGB pins. The pins going to our RGB LEDs. So there's going to be R pin. And if you remember, that was pin 37. There is G pin, and that was pin 35. And there was blue pin, and that was pin 33. Okay. Now we also had the buttons, the red button, R but. That is going to be equal to pin 11. If you remember, there was G but for G button, and that was pin 13. And then RGB but, and that is 15. Also, do you see how I like to kind of use sets of those GPIO pins that are adjacent? In that way, it's kind of easier to keep track of those numbers. So we've got those all set up. Now we've got to keep track. Is the red button up, or is it down? So that is going to be the R button state. and that will set to 1 because with an internal pull-up resistor, if we're not pressing it, it is in 1. So we're just assuming that it's natural that when you start to program, nothing has been pushed. So we're just going to start with it in state 1, and then R but state old is going to be equal to 1. Because, right, what is a button push when it's down, when it's 0, and then it goes for a 1? So we're looking for a transition from 0 to 1. So I've got to know button state, which is where it is now, and then I have to know the button old state, which is where it was before. And so I need to do one quick little video management thing here, if you would be so kind as to let me have a second. Okay, sometimes I got to refresh the camera because it gets a little tired. So that should be, we should be good to go there. So now if I have an R button state, I'm also going to need a G but state, and that's going to be equal to a 1, and then a G but state old, and that's going to be equal to a 1. It is typical to use an equal sign instead of a closed bracket, and so we will go with the standard there. And now RGB, B but state equal 1, and then B but state old equal 1. So do you see how fast you can go R but, G but, B but, it's RGB, and then I'm using similar names for the different channels, and so it just really kind of helps it go along quickly there when we do it that way. And so I hope you guys will learn how to name your variables well and to sort of keep track of things well. All right, so now we have those button states. What we are also going to need to know is what is our I don't think we need to know the state of the LEDs. Maybe, I'm just thinking we're just going to keep track of, now we don't need to know the LED state because we're keeping track of the duty cycle because we're going to be using PWM. Guys, we're ready to start setting up our GPIO pins. GPIO.set mode, and that is going to be GPIO.board. That is using the physical pin numbers. Okay, now we're going to need to do GPIO.setup, and what are we going to set up? We are going to set up our R, but no, we're going to set up our R pin, and that is going to be a GPIO.out like that. So that is setting the red LED pin to an output, then GPIO.setup, and then the G pin GPIO.out like that. And can you guess? GPIO.setup, and then the B pin is a GPIO.in. No, it's an out as well, like that. Just making sure you guys are paying attention. All right, so we got those set up. And next, we are now ready to set up those input buttons. We're going to set up our buttons now. And remember, we've got to set those pull-up resistors when we do those internal pull-up resistors, because I didn't put pull-up resistors in our circuit here. So we're going to jump in and we are going to say GPIO.setup, and this is the red button, the R but, and that is going to be GPIO.in, and now we got to set the resistor. So it's going to be pull up down is going to be equal to GPIO.pullUpDown underscore up, like that. We're putting in a pull up resistor. GPIO.setup, whose turn is it? It's G but's turn, and it's GPIO.in pull up down is equal to GPIO.pullUpDown, and it will be a pull up resistor. And now we will do a GPIO. Man, that might have been behind my head, and if it was, I'm sorry. Let me go ahead, get down here. Okay, GPIO.setup, And whose turn is it? B, button's turn. And GPIO dot in, pull up, down, pull up, down is equal to GPIO dot pull up, down. And this one will be a down. Just kidding. It will be an up as well. Just want to make sure you guys are awake. All right, so we got those done. Now we need to go ahead and set up our PWM on each one of those. So I'm going to say my PWM for the red channel is going to be a GPIO.PWM. And which pin is that hooked to? It's the red pin. And we got to think, is it the red pin? Yes, we're sending PWM to the LED, and the LED was using the red pin, green pin, blue pin. We just got to keep track of the difference between the buttons and the pins on the LED. Okay, and so that we're going to set at 100 Hertz, and then my PWMG is equal to GPIO.PWM, and that's the G pin, and that'll be 100. My PWMB is equal to GPIO.PWM, and that is going to be red, green, blue pin. And that's 100, and you guys see my mistake. It doesn't count as a mistake if you change it before you run it, and so it's as if that little thing never even happened there. Okay, I'm also just kind of glancing up. Do you see the other nice thing about the consistent naming where I have here the R, the G, and the B? Everything else should be identical, so I can just scan along here and I can see that things are looking good. And so I'm just kind of scanning my code, and it all looks good so far to me. Maybe you guys have seen something, but it looks good to me. Now let's go ahead and let's start those PWM channels. And when I start them, we have learned that you can use a 0 duty cycle, which is like constantly off. And so I'm going to go ahead and I'm going to, let's just say DC are the duty cycle for the red. I'm going to set at 0.9. And then the duty cycle of the blue, I'm going to set equal to 0.9. And the duty cycle of the blue is equal to 0.9. Remember, I said you should always go RGB, RGB, RGB. So I need to go RGB and not go RBG. It's RGB like that. Okay, now why did I set it to 0.9? Because the way I'm going to do this, remember, these colors don't respond linearly, and so we don't want to step the color value linearly by like adding 10 to the value every time. We want to do it exponentially or multiplicatively. And the thing is, if I do a multiply, and if I start with my duty cycle at 0, and then I come in the next time because I press the button and double it, it's not going to work. So I set it at 0.9, and then if I double it, it'll come on. So I don't want it to start on, I want it to start at 0, and so this is how I will do it. And this will make sense, I think, when I do it the second time, but I'm doing it the first time here just so that you can kind of make sure that you understand it. So I'm going to do my PWM red is dot start, and where am I going to start it? At the integer value of DCR. Okay, so if DCR is 0.9, and I take the integer value of that, it makes it a 0, and now I am applying a 0. But doing it this way, now if I come in and I double DCR, what happens? I end up with 1.8. The integer value of that is 1, and it'll come on dim. So you see there's a method to my madness here. Okay, so now we'll have my PWMG.RGB start, and then the int of what? Duty cycle of green. My PWM blue dot start, and that's going to be the int of what? DC, the duty cycle of blue, close, close. All right, so this should, then everything should come on off, right? Everything should come on with a duty cycle of 0. The LED should be off when everything starts. All right, so now I think we should be ready to do our try and accept. And so we'll start here with a nice try, and then we'll go ahead and take care of our bookkeeping by doing the accept. And so what we want is when we have a keyboard interrupt, which is the Control-C, when you get a Control-C, you want to jump out of try and come down to accept. And what do we want to do down here in the accept? We want to do a GPIO.cleanup, and then I want to put a print statement in here. I'll put a blank line, and then I'm going to print, and then I'm going to say GPIO good to go, indicating that the GPIO have been cleaned up. And then I'll do another print just like that. I like to put that print statement so that when I kill the program, I can actually see that I have cleaned up the GPIO pins, because you saw in the last lesson, like from a previous work I was doing, I'd left one of those PWM signals on. And then when I came in and wrote a new program and I activated that pin, it came up in PWM. It was like crazy what was happening. And so we really want to make sure that we are getting our pins cleaned up. Hopefully you guys know to do that. Okay, so we got the tries, the accepts done. Let's come in and now let's write the real. This is where the real action happens. And so we need to start thinking about what we would want to do here. And what you know is we are going to need a loop, right? We are going to need a loop in here. And so let me come down here. And so we're going to do a while true. When is true, true, true is always true. We've created an infinite loop. It'll loop in that while true until when? Until Control-C. Then it jumps down into the accept. Now, what do we want to do here? We want to read the three buttons. And so I'm going to say R but state is equal to not ru, R but state is equal to GPIO dot input, and we read it from the R button, not the R pen, the R button. And we got to be careful with our case. Now we want to read all three, so G but state equal GPIO dot input G but. And again, you see, because I'm writing these variable names the same, I can very clearly see there was a mistake there, but it's not a mistake because I caught it before I ran it. And then also here, this jumps out at you as a mistake. So RG, whose turn is it? Mr. B, but state, the B button state is GPIO dot input, and that is the B button. So now I've read all of the button states. Let's go ahead and print them out just so I can kind of see visually. It'll help us debug if we need it. And so what I'm going to do is just say print button state, and then I'm going to print what? I'm going to print R but state G but state B but state. Man, I think that if I come down, okay, you can see that. I'm trying to stay out of your way. So now I print those values just because it'll help us debug seeing where are each of the buttons. And so that's I think that's kind of a useful thing to do. So we print those R but state, G but state, B but state. And now we print all those out. Now we want to see, has the red key been pressed, which means last time it was a 0 and this time it's a 1. So if R but state equal 1 and what? R but state old equal 0, that means we have gotten a actionable button press. So what do we do in that case? Well, in that case, what do we want to do? We want the duty cycle for red to increase. So I'm going to say duty cycle red is equal to, what was that multiplier that we did the math for with the logarithms that seemed to make it step to about 99 in about, it went to 99 in about 10 steps. I do believe that that number was something like 1.58. So we're going to say DCR is equal to DCR times 1.58. And this multiplier you can play with. Do you want it to go to full red color in 10 steps, in 5 steps, and 20 steps? Well, you would affect that by what number you make this. The larger you make this, the quicker it will get to full value. The smaller, the more button pushes it'll take to get to full value. I hope that makes sense, okay? Now what we are going to do is, just to see if we got into this if statement, we'll say red channel registered, like that, just indicating that, yeah, we saw a button push. Now, one thing we got to do is, if I'm at like 80 and I multiply by 1.6 and I'm greater than 100, you don't want to have a duty cycle greater than 100. Actually, you don't want one greater than 99. So I'm going to say if DCR is greater than 99, what do we want to do? We want to loop back around and we want to go back to what? DCR is going to be equal to 0.9. So we sort of circle back, and then this, of course, is a typo. So if DCR is greater than 99, then we want to make DCR what? We want to make it 0.9, so it'll circle back around. I hope that makes sense. It really should, I think. I think it's pretty clear. Okay, now what is the one thing that we want to do here while we're still in this? We now need to change the duty cycle. So my PWM red dot, what do we want to do? We want to dot change duty cycle, like that. Change duty cycle, like that. And then what do we want to change it to? The int of DC duty cycle R. Close the int, close the change duty cycle. All right, so what does this mean? This means I start at 0.9. What is the integer value of 0.9? It's 0. The LED starts what? It starts off. First time I press it, it's 0.9. Actually, I want that closer to 1, so I'm going to say 0.99. Okay, and that, I think, will get us closer to where we want to end up. Okay, so 99 is still going to go to 0. Okay, but now DCR times 1.58 should take us sort of like where we were in the last lesson. Okay, so DCR is equal to 0.99. Integer of 0.99 is 0. So if we get to, DCR is 90, we multiply by 1.58, that's more than 99. It takes it back to 0.99, which we'll write as a 0. And so the LED will get brighter, 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 and then it'll go off. And then it'll get brighter, 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 and it'll go off. So I think that should work. All right. Now, what's the one thing that we've got to make sure, a little bookkeeping that we do here? And I'm going to go ahead. What I'm going to do is I'm going to run this and see if it's working on red, because if it's working on red, then it'll be easy to do green and blue. But what I need to do is I need to do a little bit of bookkeeping, right? I need to do a little bit of bookkeeping, and that is I need to come in and I need to say R but old, R but state old is equal to R but state, like that. And then G but state old is equal to G but state, and then B but state old something is wrong there. There it is. You see that extra E showed up because the equal wasn't in the right sign. B, but state. So now I'm just glancing over this RGB, but state all the way down, but state old all the way down. And so that all looks good. And now I'm going to go ahead and just so I can keep track of things, I'm going to print the DC duty cycle for red, the duty cycle for green, and the duty cycle for blue. And what this will just be is as we're watching the LED do its show, we can kind of see what the numbers are that we're actually putting on it. So I think this will be helpful. And then don't forget that we always need to have a little bit of a sleep in here of DT, which we already set up, so that it's not just running too quickly. Okay, I think that this might work for the red LED now. I think it might work for the red button. Let's see if we have the red button working, then doing the green and the blue will be easy. So I'm going to Control X, yes, enter. And then we are going to come over here and we are going to what? We are going to Python 3 this thing, and then everyone hold their breath. Ooh, what is that Python 3 not found? No uppercase P in Python. That scared me. Okay, everybody hold their breath. The problem was one of you guys didn't hold your breath, so I need whoever you were, and I think you know who you are, you need to hold your breath. What is that? Oh, start, misspelled start in line 42. So hopefully you guys saw that. So let's look in our PWM starts. How did I not catch that? Okay, Control X, yes, enter. Everyone, hold your breath, please. No more messing around with me. Hold your breath. This channel is already in use. Okay, so what would this be? What would this be? This would be that the last time we ran it, it crashed after we set up those things. So it's saying all of these things are already in use, okay? But now it also looks like there is still a problem in line 42. So let's go back and look at that again. And what am I doing wrong here? I thought I just fixed that. My PWMB is start int. That sure looks right, doesn't it? That sure looks right. And I do set it up here. My PWMB, my PWMRGB, RPin. Those sure look right. Let's go ahead and try it. We'll get to the bottom of it, don't worry. Python 3, hold your breath. Now, what is this nonsense? Channel already in use, channel already in use. We understand all of that. Line 42, my PWMB. Sir, I misspelled it, doggone it. How could I have done that? And I thought that we had finished that. I thought that we had fixed that. But apparently, I cannot spell start. Apparently, I cannot spell start. Okay. Take that, you aggravating thing. All right. Now, this time we're going to really run it. Hold your breath. Okay, boom. At least it is running. Now, what's this saying? The button state is 111, meaning that there are no buttons being pushed. And then the duty cycles is 0.99, which is going to int to a 0, and the LED is off. And so we are going to press this red button. Hold your breath. Okay, we're going to let it out. Boom. Look at that. Shazam. We are now at a we're now at a duty cycle of 1.5, which is going to write at a 1. And so that is the dimmest possible value that we could have on that LED. It's 1 part out of 100. And so you can see it is barely lit. And then if I press the button again, it goes to 2.47. That would write as a 2. And you can see it got a little brighter, and now a little bit brighter at 3.9. That would write as a 3, and then that will write as a 6. And then you can see it's getting brighter and brighter with a 9, a 15, and then a 24. and then a 38, a 60, and then a 95. And so that 95 is close enough to 100. And so I kind of like that, whatever that 1.58 multiplier that we used. And that looks pretty good. Now, what do you expect if I press the button again? Somebody tell me, what do you expect if I press the button again? Shazam. Look at that. Who's the magic man? I'm your magic man. Look at that. It's circled back around, and then I press it again, and boom, there it is back at very, very dim. Okay, it might just be me, but I think we have the red channel doing exactly what we want it to. We just showed the red channel who's boss. Okay, so let's go in. Let's get those other two channels working really quickly. So we'll nano into this. Not too quickly because we don't want to start making stupid mistakes. But now we're going to come in and we should be able to put in, that was not what I wanted to do. We should be able to put in two more if statements. Okay, two more little if clauses. Okay, so now if, and for some reason my copy and paste doesn't work. And so we're just going to have to old school this. But if G but state, if G but state equal 1 and G but state old equal 0, then what do we have? We have a G button push. And so in this case, the duty cycle of green should be equal to the duty cycle of green times our magic number 1.58. Okay, and then we're going to print green channel registered, like that we got that button push. And then what do we need to do? We need to say if the duty cycle of green is greater than 99, what are we going to want to do then? We are going to want to, if the duty cycle of green is greater than 99, we're going to want to circle back to duty cycle of green is equal to 0.99, like that. Is that right? I'm just checking my work here. Okay, that looks good. Now, what do we need to do? We need to see my PWM of green. My PWM green is going to be change duty cycle. And then what are we going to change the duty cycle to? We're going to change it to the int of DC what? G. Okay. I'm just glancing over my work here. I think that looks good. Is that all we got to do? I think that's all we got to do. Now we're going to come real quickly here. B but state if that is equal 1, and man, I haven't had an error up here. Did you guys see that? I said B where that should have been G. So GG, and now B but state old, and let's get that right, B but state old, and if that's equal 0, then we got a few things that we will need to do. One is DCB is equal to DCB times the magic number 1.58. That looks good. Now, in the case that DCB is greater than 99, what will we need to do there? We will need to make DCB equal to 0.99er, and then we will need to go ahead and my PWMB dot change duty cycle, change duty cycle to what? Int of DCB. Could it really be that easy? Okay, Control X, yes, enter. And now I need everyone to hold their breath. Okay, at least it's running. Now, I want to be methodical, so I'm going to step through the channels one at a time. So I'm going to start here. We expect red to work, but okay, it came on 1.5, 2, 3, 6, 9, 15, 24, 38, 60, 95 is good, and shazam, it is back to 0.99, which writes as a 0. Now, the moment of truth, we're going to press the green button one time, and boom, look at that. Green came on very dim, and the green value is 1.5, writes as a 1, and then we're going to bring the green up, and look at that. Look at the green coming on up. Look at that coming up to a 95, and then boom, LED is off. We're going to step through the blue, and the blue is dimly on, and then we're going to step it on up. The lovely blue up to a 95, and then boom, back to 0. Okay, so because each one of those runs individually, we feel very confident now. And I feel that you really need to get my full facial expression, so we're going to come back to a little bit larger view so you can see the sense of excitement on my face as this is actually going to work now. So I'm going to turn red on. One click, you can see a little bit of red. Now, if I turn blue on one click, what do I have? I kind of have a magenta. Red and blue make magenta. And so I'm going to bring the red on up, okay? And you can see that it's still kind of a nice purple. We're kind of going in that purple magenta space there. And now let's go ahead and bring the blue up some more. And we'll bring the blue up to match that. And you can see that we have just a lovely magenta on here. I actually wish that you could see it live. Well, if you're doing the project, you can, but it's just this overhead camera, the studio camera, does not pick up the color of the LED very well. The LED is bright and it just sort of blows out the camera. But let's come on up. Let's see if we just bring in a whole lot of blue. Okay, and you can see that here we've got an interesting color of blue that's a blue with just a little bit of red, which makes it just a hint of purple. And then we're going to go back down, and then we'll turn the red all the way up. Okay, and I went past it, and we want to turn the red all the way up and back to that. So now we're off. Now let's kind of play with the yellow values. So I can turn on the red, and then I turn on the green, and I get a little bit of a yellow. But what you can see is there's a lot more green than red, so it's like that green LED is kind of overpowering the red. So I've got to bring the red up, and now I've got a beautiful yellow. Okay, I've got a beautiful yellow. More red is bringing it more to orange, and then if I keep bringing it up, it's turning into a very reddish orange. And then I could add a little more green to it and mix it that way. But now let's go all the way and turn those off. That one's off. Let's turn green off. And now let's play with the aquas. Okay, the aquas would be a little bit of green, okay, and a little bit of blue. And again, the green seems stronger than the blue, and so I'm going to bring the blue on up. And wow, that green is really sort of very powerful compared to the other colors. And even there, I'm seeing a lot of, okay, now I'm starting to get more of an aqua. Okay, I'm starting to get more of an aqua, and it helps if that blue was actually working. So let's try it again. Okay, the green is overpowering it, but yeah, now I am getting a beautiful aqua, and I can bring in more green, and I can bring in more blue, and I have an absolutely lovely aqua, and I just wish that you could see it in person, as beautiful as it is to my eyes here. Okay, guys, that is pretty darn exciting to me, and I hope you all were successful. Let me know if you were successful. Also, I hope that you guys are posting your homework to YouTube. Every homework that you post to YouTube, I look at every single one of them, and then I try to leave comments on them. I just like to see that there's people learning and there's people actually doing their homework. Okay, now you guys can play around with this. I'm not giving you a formal homework assignment for next week, but what I do need is I do need you guys to let me come back over here, And what I need you guys to do is I need you guys to leave this circuit hooked up and keep a copy of your code, because next week we're going to start with this circuit and with your code, and I'm going to show you some other kind of cool things that you can do with the Raspberry Pi. But I don't want to have to like recode this and rehook this up. So your homework assignment for next week, play around with this, show your friends, impress the ladies, or if you're a lady, impress your men friends with the amazing things that you built here. And then we will start with this next week. This will be our starting point for the work that we are doing in what will be the epic lesson number 14, which shall come. Watch that bird, he's going to dive. Boom. Those are called kingfishers, and they dive down into the water and come up with a fish. I like watching that too. Okay, guys, I hope you're having as much fun taking these lessons as I am making them. As always, I want to give a shout out to you guys who are helping me out over at Patreon. It is your support and your encouragement that keeps this great content coming. You guys that are not helping out yet, look down in the description, link over to my Patreon account, hop on over there and hook a brother up. Also, you can help me by leaving a like down below and by leaving a comment. If you like it and comment, that helps me with the old YouTube juice, and that means that YouTube will show this video to more people, and that's important, because the world needs more people doing engineering and coding and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. Remember, resist the metaverse. I will talk to you guys later.